Hello and welcome to today's video. Now, today we will be revisiting an older subject, an older couple of videos I've made on this channel on how to create 3D formed threads for Alibre. Now, I have described the method of creating Boolean threading dies or threading taps using the dynamic parts library. However, the dynamic parts library is only part of the Alibre Design Expert license. So what we're going to do today is we're going to cover how to create 3D formed threads for the other two licenses, right? For the Alibre Atom3D license and for the Alibre Design Expert license. For context, you will need to watch the Alibre Design Expert videos, right? The Boolean threading die and Boolean threading tap videos, because we will be using the those parts in the Alibre Design Professional method, right? But first, we will talk about Alibre Design. Alibre Atom3D. So let's start a new file, and I'm going to call it Alibre Atom3D. Okay. Well, I should have put threads in there, but we can change the name when we save. Okay. So I'm only going to use tools available in Alibre Atom3D now. But first of all, I need to create a couple of parameters, which of course you can do in Atom3D. So the thread pitch is going to be 1. I'm going for an M6 by 1 thread here. So the thread pitch is going to be 1. The thread M, I'm going to call it, or diameter, is going to be 6. And the thread height, which is an intermediate parameter that I'm going to use, is going to be cosine of 30 times the pitch. And because Alibre generally wants radians inside its trigonometric functions, we just put in the angle and then we say times 2 times pi divided by 360. And now that's in radians. So times the thread pitch. So this was, this is a unitless number. Distance needs units. So as soon as I multiply it with a parameter that has a unit, it's in millimeters, it gets that, it inherits that unit, and it's fine. So that is my thread height. Okay, so let's make a part. And let's say that this is 30 millimeters, and now this is going to be thread seconds, because I'm just going to revolve this to get the part that I want. Okay, and let's get a thread relief down here. And a chamfer start. Oh yeah, that needs to be there in the end. Okay. Yeah, playing a bit with this. So we need an angle. Let's do 160 degrees here and 120. Sorry. Again, A1 here. Okay. This thread relief would be nice if it's larger than the pitch. So I'm just, well, let's do this. Since we do have the parameter, let's just do this. Okay. Now these two are equal. I don't want them to be equal, and you will see why. Let's get this A1 as well. Ah, yes. Yeah, let's make this horizontal. So how much is the relief going to be? Well, I want it to be less than 5 millimeters, which is going to be roughly the it's actually the theoretical internal diameter of my thread. So I'm just going to say 2.4, 2.45. So that will give me a diameter of 4.9 millimeters. Okay. And I am going to have a thread length 15 millimeters. Okay, this is fully defined now, but if we get a reference dimension going, this will also have a diameter of 6 millimeters, right? And we don't want that. Why don't we want that? Because if we reference back to this image, which is really, really helpful, right? You will see that for an external thread like the one we're trying to create, we will draw our theoretical triangle here, right? Or you can consider this one. And after we draw our theoretical triangle, we would need to chop off a quarter of the thread height from the bottom. Sure, we can do that. And an eighth of the thread height from the top. Now, the easiest way to do this is by reducing the diameter of this line. So I'm just going to delete this equal constraint. And I'm going to say that this is okay, minus 1/8 times the thread height. Okay, and that is going to give me, right, so instead of 3 millimeters, you can see now that I have a radius of 2.8917, whatever, right? This is the radius I need. So now this is my correct drawing to get the thread going. And see, you can click in empty space, you get this context menu, but according to Harold's tip from the forums, you can just hit spacebar. And this is a game changer for me. I don't know, I didn't know about this before, but anyway, so we will revolve around the x-axis, and here we go. Okay, now we want to create the threads here. I want to go to a plane that is vertical, sorry, that is perpendicular to this face. So I'll go to the XY plane, and I'm just going to create a random triangle. And then I'm going to make sure all of these three are equal, and then I'm just going to make one of them horizontal. So this is the theoretical profile of a 60-degree thread, be that ISO or ANSI, right? So I want to dimension this to be equal to the thread pitch. Then I want to project this line here, but I can even project the entire cone. It doesn't really make a difference. And I want this, the start of my theoretical triangle, I want it to be vertical to this point, right? To the outermost point of my thread. And again, let me stress again that the thread starting chamfer and the thread relief, we need to make before, right, in advance. Okay, now we want to dimension this height to place this triangle, right? And we need that at a 6 millimeter diameter, because again, this is the theoretical triangle, so it gets the theoretical diameter. And of course, you need to divide by 2. Okay, and that's pretty much done for the sketching we need to do. Now we need to go to the helical cut tool, which is up here, right? It has pre-selected sketch 2 because it was active. We select this face to give it a reference line. We see it's going the wrong way, right? So let's just click reverse. Okay, and now height and pitch, yes, that's the way we want to do it. For the height, let's look for the 15 millimeter value that we had here, right? And let's add another thread pitch. Make sure it reaches our relief area, right? Okay. And the pitch is, of course, the thread pitch. Okay. We just... yes. I did forget something. So that was not, we were not done with the sketching, right? So if you go back to this image, we need to take a quarter off of this, of a quarter of the thread height off of this theoretical profile. So how do we do that? We just put a vertical line here. We dimension it. Okay, so this is a quarter times the thread height. Okay. Now you just select these two. Sorry, you just select these two, convert to reference figures. I have it as a hotkey, but I just wanted to show you. And you add a geometry line here and a geometry line here. I've already made the helix, so it will update. And there you go. Apparently, I need to give it more of a relief here, which is fine. Let's come, oh, no, not this. Let's come back here and 2.3. Regenerate. There you go. That's a nice thread. Okay. So there you go. Now you have, let me hide my planes with Alt3. So now you have a pretty good thread here. Now, why did I do it this way? Why did I go to all that trouble to create, to make everything parametric? Because now I can come in here. Let's make these 3 favorites. Let's sort by favorites. There you go. By the way, this is a calculated parameter. We don't need to make it a favorite. So now let's say that so this is a short stud, right? Let's make this a favorite. I'm just making it as I go along. Okay, so let's say that this is the thread length. Okay. Okay, so now let's make an M10 by 1.5. And I only need 12 millimeters of this thread. Let's hit OK. There you go. The relief isn't parametric. Let's go make it parametric. So to make sure that we get a good relief, I think that if we say that this is equal to the thread height, we should be fine. And let's check. Yeah, there you go. Math is fun. Okay, so yeah. So basically what you have now is a parametric threaded stud, right? You can do what you want with it. Changing these values will update the design. Okay, and this is how you do that in Alibre Atom3D. Okay, so let's save that. Threads. Yep. Now, another part. So we'll call this Alibre Pro. Right. So in Alibre Design Professional, you don't have these, right? But you do have the Boolean subtract capabilities. Okay. So what you can do is you can let's take as an example, right? Let's take the threading die. Okay, it's the exact same operation to make the Boolean threading tap. You design the threading die, and because I do have expert, I'm just going to yeah, I'm just going to generate it. So I want an M6, not M, M6 by 115 millimeters long. Finish. Okay, there you go. This is it. So this is the Boolean threading tab. If you want to know how to design this, you can reference the Boolean threading tab video and the Boolean threading design video. I will have cards to them up here. So you have made this, okay? After you make this, you will save it as a file, right? I even would suggest that you make a folder with these things. Okay, and we will call this Boolean M6 by 1 die. Okay, so we made this. Now that's cool. Okay, so let's go now. Let's minimize this. Now let's go and use it somewhere. So this is the threaded base, I'm gonna call it. And I'm just going to make a disk with 2 pillars now instead of 3 that I had done in my other video. That's fine. Let's make this a 10 millimeter. And let's make a, well, I don't know, an M4 here. Okay. Let's make sure these are horizontal and that they are at an equal distance from the center of 35 millimeters. Very nice. By the way, that trick I did with a midpoint constraint, I have a video about that as well. I'll give it to you in a card up here. Okay, so let's extrude these for 20 millimeters. Okay, let's get the chamfers going because, as we said, it is best if we get the chamfers going ourselves. 60, well, yeah, to be honest, you need 2 different chamfers here. So this is an M10 by 1.5. The chamfer should be a bit more than half the thread pitch. Or should I just give it a thread pitch as a chamfer? Let's see. 1.5. That's too much. That's fine. Oh, wait. 30 millimeters. Yeah, the other way. Another tip from Ty. You highlight the surface, control, double click, and you can edit the feature that created it. Thank you for that, Ty. Oh, there you go. That's nice. Now let's get the other chamfer going. That's going to be an M4 by 0.7, so this can be a 0.4. What do we do now? We have an M6 threading die, but I want to create an M10 and an M4, right? And I have neither of those dies. So I will go and open up the threading die that I already have, right? Which I made with the method I described in the video. And I come in here and I've got all of my parameters here. So I want an M10 by 1.5 and a length of 15 millimeters. That's fine. I hit OK. This changed, right? So now we'll save it as a Boolean M10 by 1.5. Well, yeah, 1.5. I don't like using dots in file names, but yeah, whatever. Okay. So I've made one of the dies I need. Now let's make the second one. The other one is an M4 by 0.7. Hit OK. File, save as. So this is an M4 by 0.7. Okay, now I have the 2 threading dies I need, and I will go start the Boolean subtract operation. Let's add this in. Okay. Let's add this one in as well. And from now on, it's the same operation as my design expert video. I just constrain it here with fastener constraint. That's nice. And here with another fastener constraint. I click OK. There you go. Really, really nice threads. Right? Well, the chamfers didn't come out very nice. Yeah, I don't like them. Let's make them bigger. You know what? Let's give this 1.5. Cool. Let's make this 0.7. So the thread pitch. I think I remember I did this in the other video. Yeah, that's a lot better. Yeah, significantly better. So you see that the way to do it in Alibre Design Professional is very, very, very similar to how you would do it in Expert, right? You might not have the generatability, right? So it will take slightly more time because you need to open up one of the dies you already have, insert the new parameters, and save as. But yeah, that's the difference basically. And now you know how to make 3D formed threads for all three flavors of Alibre. So that's Alibre Atom3D, Alibre Design Professional, and Alibre Design Expert, based on the methods in the videos I had created previously. If you like this video, please subscribe because more are going to be on the way. Hit the like button, that helps a lot, and leave a comment, that helps even more. I'd love to know what you are going to make with these methods, and yeah, see you in the next one.